Welcome to the deep dive. Ever wonder what's really going on inside your smartphone? I mean, beyond the screen you're tapping.
Chances are, yeah, a lot of that core tech comes from a company called Qualcomm.
Exactly. They might not be, a brand name you think of daily, but they are absolutely huge in wireless. And they're branching out.
Oh, definitely. Qualcomm's tech is kind of the hidden engine in so many phones, powering our 5G, for
Wow.
instance. But their story, it goes back 40 years, way beyond just phones.
Right. So today, we're digging into that. We've got this great resource covering, well, everything. The history, the people, what they're up to now, competition, the money side.
Yeah, it's pretty comprehensive. Think of this as your shortcut to understanding a really key tech player, and honestly, what shapes a lot of our mobile future.
That's the mission for this deep dive.
Mm-hmm.
Break down how Qualcomm got here, what they're innovating on right now, and maybe pull out some lessons about tech itself. We think there'll be some surprises.
Should be interesting.
Okay, so let's start at the beginning. How did this giant actually, get started?
Well, it all kicked off back in 1985. Erwin Jacobs and six others, they came from another company, Linkabit.
Link a bit, okay.
Yeah. Jacobs, he'd been a professor, MIT, UCSD, had a vision. And the name, Qualcomm. It's short for Quality Communication.
Quality communications makes sense.
Initially, though, they were doing contract R&D, mostly government defense work, building specialized communication systems, that kind of thing.
So pretty far from the phones in our pockets today. What was the first big thing that clicked for them?
That would be Omnitrust CS, launched in '88. It was basically a satellite messaging system for the trucking industry.
For truckers. Okay, didn't see that coming.
Yeah, really early digital comms for long-haul drivers. And that steady income, it let them fund a really daring bet.
Which was?
CDMA, code division, multiple access, a totally different way to handle mobile calls.
How different?
Well, instead of slicing up time or frequency, it used unique codes. Think of it like multiple conversations in one room, but each in a different language.
Yeah.
Allowed way more calls on the same frequency, much more capacity.
Wow, okay. That sounds like a serious leap. Did it work?
It did. 1989, they made the first public CDMA call right there in San Diego. Success.
Huge moment.
Absolutely pivotal. Proved the tech worked. Still took a few years for the industry to really, catch on. There were other technologies, big hurdle.
Right, it wasn't an overnight switch.
Not at all. They had to really push, demonstrate the advantages, convince the carriers. But they got there.
So fast forward a bit, maybe mid-90s,
Yeah.
they're not just an R&D shop anymore, they're becoming a money machine. What happened?
1995, that was the year. U.S. carriers decided, okay, CDMA is the way forward for our new digital networks.
Ah, the tipping point.
Exactly. And here's the genius part. Qualcomm held the key patents for CDMA, the fundamental stuff.
So they own the standard, basically.
Pretty much, their model became no license, no ships. If you wanted to build a CDMA phone or network, you had to pay Qualcomm a royalty.
Wow. Talk about strategic positioning, like setting up a toll booth.
That's a good way to put it. And then another smart move in '99, they had a network equipment division making actual base stations and stuff. It was losing money.
Yeah.
They sold it to Ericsson. They realized their real strength, their core value, was the IP, the patents, and designing the chips, not building the heavy infrastructure.
Focus on the brains, not the brawn.
Precisely. Double down on licensing and chip design.
Okay, so patents locked down, focus sharpened. Then comes the smartphone wave.
Yeah.
How did they ride that?
Snapdragon. That's the key name here. In 2007, they pulled off this amazing integration.
What do they integrate?
The modem, for the cell connection, the CPU, the phone's main brain, and the GPU for graphics, all onto one single chip.
Whoa. A system on a chip.
Exactly. And so super efficient, packed everything essential onto one piece of silicon. The first Snapdragon phones hit the market that year.
And took off in Android, right?
Big time. Became the engine for so many early Android devices. Huge advantage in performance, battery life.
Makes sense.
And they kept adding pieces. 2011, they bought at Theros for about $3.1 billion. Big number.
What did Theros bring?
Wi-Fi and Bluetooth. Brought that tech in-house. So by the time 4G rolled around, Snapdragon was just dominant in high-end phones. The default mobile phone engine, as one source put it.
Incredible journey. From satellites for trucks to the heart of the smartphone. But tech never stands still, right? Next up, 5G. Sounds like that era brought new tech leadership, but also some major battles.
Yeah, the race to 5G was intense. And Qualcomm, true to form, launched the first 5G modem, the X50, way back in 2016, before the networks were even really built out.
Staying ahead of the curve.
Always. But yeah, there were bumps. That huge $44 billion deal to buy NXP, it fell through in 2018. U.S.-China trade tensions got in the way.
Ouch, that must have hurt. And then there was the big fight with Apple.
Oh yeah, the Apple war.
Yes.
Very public, very complex fight over patent licenses. Dragged on for a while.
How did that end?
Big resolution in April 2019 that basically called a truce, dropped all the lawsuits. Apple signed a 6-year license deal and a multi-year chip supply agreement.
So Qualcomm came out on top there, it sounds like.
It was seen as a major win, yeah. Then, looking beyond phones, they bought Nvidia in 2021, cost them $1.4 billion.
Nvidia, what was the goal there?
High-performance CPUs, custom designs. The plan was, and is, to use that tech in future laptops, maybe even phones, to really compete on performance.
Interesting. So that brings us pretty much up to today. Smartphone sales are slowing down a bit globally. Qualcomm's clearly looking elsewhere now.
Absolutely. Diversification is the name of the game. They're pushing Snapdragon into cars, laptops, mixed reality headsets. You see them in the Meta Quest 3, for example.
Right.
But maybe the biggest shift, on-device AI. Artificial intelligence running right there on your phone or device, not just in the cloud.
On-device AI. Tell me more. That sounds different.
It is. The idea is to do complex AI stuff locally. Think like having a powerful calculator built right in instead of sending every problem off to some giant remote brain.
Advantages being speed, privacy.
Exactly. Speed, reliability works even if your connection is spotty, and better privacy since less data leaves your device. And their latest chip, the Snapdragon 8 Gen 3, it can run pretty hefty generative AI models locally, up to 10 billion parameters.
10 billion. That sounds like a lot. What does that mean in practice?
Well, parameters are like the knobs the AI uses to learn. More knobs generally means a smarter, more capable model. So running a 10 billion parameter model on your phone, that's pretty impressive. Means sophisticated AI tasks without needing the cloud.
So my phone could do things like summarizing text or maybe generating images all by itself.
Potentially, yeah. And they're building the ecosystem. IBM's optimizing its Granite AI models for Qualcomm's AI hub so businesses can run AI on Snapdragon devices. They even bought the AI division of VinAI, a Vietnamese company, just recently.
Bringing in more expertise.
Machine learning, computer vision, language processing, strengthening their AI bench.
And you mentioned seeing this at shows like CES?
Right, CES 2025, they were showing off AI chatbots and like washing machines, TVs, robots, all running locally on Qualcomm chips. Gives you a taste of where they see this going. AI everywhere, basically.
Wild. Okay, but connectivity is still their bread and butter, right? Are they still pushing limits there?
Oh, absolutely. The new Snapdragon X85 modem, it can hit download speeds up to 12.5 gigabits per second. That's incredibly fast. And it uses AI to manage the signal better, save battery.
12.5 gigs.
Ah.
Wow.
Yeah. And they have stuff for wireless home internet, too, using 5G to deliver fiber-like speeds wirelessly. Big for areas without good wired options. Plus, their Open RAN solutions that's about making mobile networks more flexible are getting picked up by carriers in places like Vietnam and Japan.
And they're already thinking about 6G, I assume.
You bet. Early research is well underway, looking at even higher speeds, more AI integration into the network itself.
Okay, so AI and connectivity is still huge. What about those other hardware areas? Cars seem like a really big push.
Massive. Automotive sales hit $2.9 billion last fiscal year, but the pipeline. They have $45 billion in future business locked in through design wins.
$45 billion. That's enormous.
It really is. They're partnering with everyone, Leapmotor, Mahindra in India, Sony Honda for that Afeela EV. Their Snapdragon digital chassis is becoming this central platform for the car's electronics. Infotainment, driver assistance, connectivity.
The car's brain and nervous system almost.
That's a great analogy. They're working with Amazon for Alexa in cars, Garmin, Panasonic. Automotive revenue just keeps climbing, nearly $1 billion last quarter alone. It's a huge growth engine for them now.
Okay, cars are big. What about laptops and XR, that's virtual and augmented reality?
Laptops, they've got the new Snapdragon X series chips, competing directly with Intel, AMD, Apple. The pitch is performance, great battery life, and built-in 5G.
Taking on the incumbents.
Yep. And XR. Their chips power over 60 devices already. Think Meta Quest headsets. Focus is on better visuals, less power drains, smoother experiences. And then there's IoT Internet of Things. Low-power chips for all sorts of connecting gadgets, often with the SIM card built right in.
So they're really spreading their bets. This kind of transformation needs strong leadership. Who are the key figures driving these shifts over the decades?
Definitely. Looking back, the founders were obviously critical early on. Irwin Jacobs with the CDMA vision and the royalty model, Andrew Viterbi, the math genius behind CDMA, Hervey White nailing those early Omnitrace ES deals that funded everything. That's kind of the 85 to 2004 era.
Got it. And the smartphone boom.
That was largely Paul Jacobs, Irwin's son, as CEO. He drove the Snapdragon launch, really pushed the data-first smartphone idea, and Franklin Antonio, another co-founder, was the key chip designer, the hardware guru for their early radio and SoC stuff. That takes us up to around 2014.
And more recently.
Steve Mollenkopf was CEO from 2014 to 2021. He navigated the 5G transition, shipped that first modem, and crucially, settled that huge Apple fight.
A critical period.
For sure. And since 2021, it's been Cristiano Amon. He's the one really driving this big diversification, push cars, PCs, XR, and the heavy focus on on-device AI.
Seems like each leader tackled the big challenge or opportunity of their time. So today, under Amon, where's the R&D money really going?
Big investments, $8.9 billion last year alone. That's nearly a quarter of their sales.
Wow. On what?
Three main buckets, really. One, on-device AI, making it smarter, more capable. Two, 5G evolution and the path to 6G. And three, all that diversification cars, XR, PCs, IoT.
They seem serious about reducing reliance on just phones.
Very. They've actually set a target. Get automotive and IoT combined to make up 50% of their revenue by 2030.
50%. Where are they now?
Right now, it's about 25% combined based on the latest quarter. Cars are around 9%, IoT is around 15%. So still a way to go, but that's the goal.
Ambitious. But they're not alone in these spaces. Who are they actually competing against day to day?
Depends on the market. It's pretty fragmented. For phone chips, you've got MediaTek's Dimensity, Samsung's Exynos, Apple's A series and their developing modem, Huawei's Kirin in China, Unisoc. It's crowded.
Okay. Laptops.
Big guns there. Intel's Lunar Lake, AMD's Ryzen AI, Apple's M series chips. Tough competition.
And cars. Those brains.
Nvidia's Drive platform, Mobileye's IQ chips are major players there.
What about XR?
Apple's Vision Pro silicon sets a really high bar. And even in things like radio frequency components, they compete with Broadcom and Qorvo. So yeah, battles on many fronts.
Keeps them on their toes, I bet. How does all this activity shake out financially? Where did the money actually come from?
Well, despite all the diversification talk, phone chips are still king. Around $25 billion in revenue, roughly 64% of the total for 2024 and the first half of 2025.
Still the biggest slice.
By far. Licensing, though, that patent royalty stream, it's steady, very high margin, brings in about $5-6 billion a year, maybe 14% of sales now after a little dip in 23. It's reliable cash.
And the growth areas. Automotive and IoT.
Automotive is climbing fast. Like we said, $2.9 billion in 24, up from just $0.6 billion in 2020. It's about 9% of revenue now, but that $45 billion backlog is huge. IoT is also significant, around 15% currently.
Where in the world are they selling most?
Geographically, China and Hong Kong are the biggest chunk, almost half their revenue in 2024. Then the U.S. is about a quarter, South Korea around 20%.
And the stock.
Yeah.
Has it been good for investors?
Long-term, absolutely incredible. If you put $100 in their IPO back in 91, you'd have something like $45,000 today.
Wow.
Yeah. Even just the last 5 years, the stock's doubled. So despite challenges, they've delivered significant growth.
Okay, that's impressive context. So looking forward now, what are the tailwinds pushing them forward? And what are the headwinds, the challenges they need to navigate?
Good question. Tailwinds, definitely these huge new markets, Snapdragon and PCs, the whole automotive boom, billions in potential revenue there. On-device AI could be a real differentiator, making customers stickier, maybe saving them cloud costs, and that steady royalty income just keeps funding new bets.
Sounds promising. What about the potential dark clouds?
Headwinds, well, they're still very reliant on phone chip sales, right? 2/3 of their chip money comes from phones, so a big downturn there would hurt. Apple building its own modem, that's a big one. Could impact royalties, chip sales to Apple eventually.
The Apple factor again?
Always looms large. And then just the general uncertainty regulations, export rules changing. For a global company like Qualcomm, that can always impact market access or licensing deals.
Constant vigilance required. Okay, we've covered a ton of ground, 40 years of history and innovation. If you had to boil it down, what are maybe 5 key takeaways from Qualcomm's success story?
Okay, 5 key things. 1, bet big on the right tech, early CDMA, patent the heck out of it, and build a business model on those royalties.
What's the patent power?
2, be willing to ditch things that aren't working, like that base station unit, and focus ruthlessly on your strengths. In their case, IP and design.
Strategic pivots?
3. Integrate early and iterate fast. Snapdragon, combining everything, set the Android standard and made it hard for others to catch up.
First mover advantage in integration.
4. Stay ahead in connectivity. They've led the charge in basically every wireless generation, 2G, 3G, 4G, 5G, always first or among the first.
Consistency and innovation.
And 5. Recycle profits. Take the money from mature markets, like phones, and plow it into the next big things. Cars, IoT, XR, PCs. Don't stand still. Reduces risk, opens up growth.
Bit, patent, pivot, integrate, reinvest. Sounds like a powerful formula.
It's worked well for them for 4 decades.
So wrapping this up, it's really a fascinating journey. From that risky CDMA bet to being so central to mobile and now this big push into AI everywhere, cars, everything else. What are the big aha moments for you from this deep dive?
For me, it really underscores the sheer power of intellectual property when managed strategically. It's also about the courage to make those big pivots, like selling off hardware to focus on IP and just the relentless pace of innovation required. You can't rest.
Absolutely. That need to constantly look ahead.
Yeah, and their ability to not just react to shifts, but to actually anticipate and lead them. From CDMA to 5G to on-device AI, that foresight is impressive.
Definitely. And for you listening, we hope this gives you a clearer picture of a company that, well, maybe not always visible, is deeply embedded in the tech shaping our world. It offers real lessons in business strategy, innovation, and just how fast things change.
Makes you wonder, doesn't it?
It really does. Thinking about Qualcomm's history of disruption, what's the next big shift they might jump on? What future tech are they positioning for now that we haven't even talked about? And what would that mean for all of us, for the gadgets and services we use every day?
Something to keep an eye on for sure.
Absolutely. It's a story that's far from over. Thanks for joining us for this deep dive.